All right, we've got 6 minutes to do this one problem. Should be enough. It says to find dy dx for that equation. So what do you notice about that equation, first of all? It's unsolved for y. Good. It has two y's in it. Would you like to try to solve for y, or do you think we're going to be able to solve for y? I don't think so. First of all, one of them's squared, so anytime it's squared like that, or even any even power, it's going to require two equations, which we'd rather work with one. And then, of course, the other y is trapped in the exponent. So releasing one traps the other and back and forth. So we're probably not going to solve it for y. We have a way to solve or to find the derivative implicitly. So let's go ahead and do that. We'll take the derivative of both sides. And you can do it like this if you want, d dx colon. Thank you. We just started example 8. d dx colon means I is about to take the derivative with respect to x of both sides. So we have 1, 2, 3 terms. The derivative of the first term is itself, right? The derivative of e to the blob is e to the blob, times the natural log of e, which is 1, so we don't need it. E is the only one who's its own derivative. But now we have an exponent that's not just x. So times the chain rule with parentheses, right? Because it's two factors. It's going to generate two terms. So it's 1 times y plus x times the derivative of y with respect to x. And again, if those parentheses were not there or brackets or something, it would be wrong because that e to the xy ultimately has to get distributed. So that takes care of the first term. Plus the second term is 2x times the chain rule dx dx, which we don't need. And then minus the derivative of y squared is 2y times dy dx, which we do need. And on the right, what's the derivative of 10? 0. Yeah, that's an easy one to still call 10. Or at least for me, I do that sometimes. So now we have to combine our terms that have dy dx in them, and that one over there on the left is trapped. So I have to spring them by distributing. So if we do that, we get y e to the xy plus x dy dx e to the xy plus 2x minus 2y dy dx equals 0. So just distributing it, expanding it out. And now we'll collect our dy dx on the left. Both terms are already on the left, so if we factor it out, you get x times e to the xy minus 2y equals. Now everything that I didn't underline can go over to the right-hand side, and their terms change sign. So they're both negative now. So negative y e to the xy, and then minus 2x. And we're almost there. All we have to do is divide through, and negative y e to the xy minus 2x all over x e to the xy minus 2y. So that's a perfectly acceptable answer. No problem. But if this were like a free response, what they would say is probably show that dy dx equals that. And they will give you a version to shoot for. Or if it's a multiple choice question, of course, it could be different than that. This is probably not how I would leave it, simply because we have 4 terms, and of the 4, 3 of them are negative. So here's a case where we would probably just multiply by negative 1 over negative 1 and get the other version of it, which would now make them all positive. So I'm just going to call that 2x plus y e to the xy all over 2y minus x e to the xy. Kind of putting the bigger terms at the back. That's probably the better version. So that would be the multiple choice answer, or the one on a free response that would say show that dy dx equals that. In which case, when it says to show, it's kind of like a proof. You want to make sure you show each and every step. Now, if you would have collected your dy dx's on the right-hand side instead of the left, that's what you would have gotten originally. Okay? So that was an implicit differentiation problem, but it was also an exponential rule problem. Okay? Because it was base e raised to some power. So after lunch, we'll do example 9 and 10. 10 has a little bit of creative element to it because we get the cold milk guy. And every year, I always catch people as we're working through the boring problem about milk. It's irresistible to doodle on this guy. And so I have a collection of doodles for the cold milk guy from years gone past. And we'll share those with you. The ante gets upped every single year on how to doodle the cold milk guy. It was very simple in the beginning, but anyway, it's kind of become a tradition. So you're going to be invited to participate in it, but it's not a requirement. All right, so 2 examples after lunch. Lunch will be here in less than a minute.